Scientists have successfully reversed age-related memory loss in mice. This discovery could lead to the development of treatments to prevent memory loss in people as they age. Recent evidence has emerged of the role of PNNs in neuroplasticity and to make memories. Neuroplasticity is the ability of the brain to learn and adapt. PNNs are cartilage-like structures that mostly surround inhibitory neurons in the brain. Their main function is to control the level of plasticity in the brain. PNNs contain compounds known as chondroitin sulfates. Some of these, such as chondroitin 4-sulfate, inhibit the action of the networks inhibiting neuroplasticity. Others, such as chondroitin 6-sulfate, promote neuroplasticity. As we age, the balance of these compounds changes, and as levels of chondroitin 6-sulfate decrease, so our ability to learn and form new memories changes, leading to age-related memory decline. Researchers investigated whether manipulating the chondroitin sulfate composition of the PNNs might restore neuroplasticity and alleviate age-related memory deficits. To do this, the team looked at 20-month-old mice considered very old, and using a suite of tests showed that the mice exhibited deficits in their memory compared to 6-month-old mice. For example, one test involved seeing whether mice recognized an object. The mouse was placed at the start of a Y-shaped maze and left to explore two identical objects at the end of the two arms. After a short while, the mouse was once again placed in the maze, but this time one arm contained a new object while the other contained a copy of the repeated object. The researchers measured the amount of time the mouse spent exploring each object to see whether it had remembered the object from the previous task. The older mice were much less likely to remember the object. The team treated the aging mice using a viral vector. This virus was capable of changing the amount of chondroitin 6-sulfate. The researchers found that this completely restored memory in the older mice to a level similar to that seen in the younger mice. The team saw remarkable results when treating the aging mice. The memory and ability to learn were restored to levels they would not have seen since they were much younger. To explore the role of chondroitin 6-sulfate in memory loss, the researchers bred mice that had been genetically manipulated such that they were only able to produce low levels of the compound. Even at 11 weeks, these mice showed signs of premature memory loss. However, increasing levels of chondroitin 6-sulfate using the viral vector restored their memory and plasticity to levels similar to healthy mice. The team has already identified a potential drug licensed for human use that can be taken by mouth and inhibits the formation of PNNs. What is exciting about this is that although the study was only in mice, the same mechanism should operate in humans since the molecules and structures in the human brain are the same as those in rodents. This suggests that it may be possible to prevent humans from developing memory loss in old age.